about to miss this. Everything that you're about to witness. Get up, come out and try to get this. This is all a part of my sickness. But listen up, cause you're about to miss this. Everything that you're about to witness. Get up, come out and try to get this. And this is all a part of my sickness.
Hello and welcome to Crack the Cred, the show that takes a mystery out of cracking passwords or finding ways around them. I'm your host, Dana Epp, and today we're going to talk about password hashing, specifically how it works on the web. I have received tons of emails and comments and questions about just what's going on, because in the last couple of weeks there's just been so much compromise and so many passwords that have been leaked on the internet from things like LinkedIn and Last.fm and eHarmony, and people are getting confused. They don't understand how this day and age it is so easy for people to recover these types of values. And I'm just going to show you how easy it really is. We're not going to talk about the attack vector of actual infiltrating and retrieving the passwords as they're stored in the database, but we're going to talk about what we could do if we had some way of getting the information or gaining access to it. In the case of things like eHarmony and LinkedIn, we've been finding that they're just using simple hashing algorithms. And there's nothing wrong with using hashing. Actually, it's a better way of going about it. For years, we've been sitting there and people have been storing passwords in clear text in these databases, which was a really bad idea. So people heard, hey, it's better to run it through a cryptographic hash algorithm like MD5, and that would be a better way to go about it. The problem is people have been implementing it very incorrectly. The aspect of just taking plain text and pushing it through a cryptographic hash like MD5 and then storing that ciphertext in a way isn't enough. And the reason is that it's just quite easy to pre-compute those values and be able to leverage or look them up. Or in many cases, even just brute force cracking on something as simple as a laptop, you can recover that information very, very quickly. So I'm going to just show you how easy this really is. So in the case of what we saw with the eHarmony, some of that information got leaked about the types of hashes that were there and what was used. So I was able to get my hands on some of them, and here's an example I have here of one of the actual hashes that were used. So if we load up Kane and take that hash, what we can do is head over to the Crackers tab, and we can go to the MD5 section, and then we can actually go and add it to the MD5 hash table here. And we can then run through and attack it. Several ways that we could do this. The first way we could do it is just run a brute force analysis. We'll just run through here right now. I'm just going to select as the char set to use. I want to check against everything. We don't know what's in here. We don't know what's happening. So we're going to do uppercase and lowercase and numbers and special characters. And we're going to run it between 1 and 16 characters, which is probably going to be more than enough on here. And if we go and run this, we can see that in almost no time at all, it's returned and it's done. And this is one of the most popular passwords that was used on eHarmony. It's love. It's one of the common passwords, and well, a lot of people were using it. But did you see how quickly that came back? It was insane. Now, we can go through and try a different hash here. If I go back to that hashing dump, there was another one that was here. And if we zip back to Kane, do the same thing again. Run another brute force. Again, we'll use all character sets. Hit start. This is going to take a little longer. And there you go. Didn't take that long, but in the end, just by adding one extra character, in this case, lover, it was able to find that information rather quickly. Now, we could go on and on. Every time you add some more characters or special characters, it gets more complicated. But the reality is, this is from a simple brute force on a little laptop. If we do this through a dictionary, do this through rainbow tables, it will be an almost instantaneous recovery depending on what's going on. More importantly though, we don't need the fanciness of having terabytes of rainbow tables to actually do this stuff. I'm going to show you another way you can get into this. I'm going to show you a third type of hash that we have that comes again from these capabilities that we've found by doing analysis on some of these password dumps. And we're just going to zip up here over onto Google, something as simple as Google. The reality is we may not need to actually brute force it at all, store the data. If I can just take that hash, place it in Google and do a search, boom. instantly I found that here we are. I just went from finding a 4-character password, which took almost not even a second in Kane, to doing a 5-character one that was found in a couple of minutes, right down to using Google in less than a second, getting a 6-character with special numbers. So in the end, it is very easy to find these. They're indexed, they're out there. We shouldn't be using things like MD5. Now, if you have to, what's the answer to this? Well, the first thing is that we shouldn't be using raw hashing like this. We should be salting the data. It's really not that difficult to sit there and make sure that as we're going through that process, we append or prepend to the password a unique value that only belongs to that system, or better yet, to that user account. Anything we build, if we have to store a password, we're gonna push it through a much stronger hashing algorithm like SHA-512, and then we're gonna hash it against a unique value that is tied to that user account, so that we never have to worry about this being applied through a rainbow tables methodology. So there you have it. It's really that simple. Hashing algorithms by themselves are not going to be the panacea to protect us against this stuff. Developers of these sites need to be stronger and think deeper. They have to be making sure we're using stronger hashing algorithms to start with, like SHA-512. Hey, MD5, the author, he even says it's not strong enough anymore. We should stop using it. And more importantly, as we start seeing on these, everything from our emails that may store these hashes as links to get into sites, we need to be screaming at these vendors, making sure that they know and understand what they're doing, and more importantly, that they're taking advantage of using better algorithms to keep us safe. If you're not sure, ask them. That's the whole reason that they're there, is to meet our needs, make sure that they're doing it right to protect your interests.